Hey, good morning, everybody. Welcome to NVIDIA's webinar. Today, we'll talk about NVIDIA Jetson Thor, our newly launched Edge AI processor, robotics processor. And today, we'll have some amazing news to share with you. We'll talk about how you can accelerate robotics and real-time AI inference on NVIDIA Jetson Thor. So let's get started and look at what we got to cover today. But before we jump into the agenda, I do want to introduce our team here. We have amazing speakers today. I will first introduce myself and then my colleagues. My name is Chen Su. I'm the Senior Product Marketing Manager here at NVIDIA. I lead product marketing for NVIDIA Jetson platform. And here with me, we have Ayush. Ayush, introduce yourself.
Hello, everyone. Good morning, good afternoon, good evening, depending on your time zone. I'm Ayush Padang. I'm the hardware product manager for Jetson product line at NVIDIA.
Hi, my name is Chitoku Yato. I'm technical marketing manager leading Jetson technical marketing engineering team here NVIDIA Santa Clara headquarters.
Great. And today we will have different people with different expertise cover different topics. So let me first introduce what we're going to cover today. To begin with, I will talk about and introduce you the NVIDIA Jetson Thor platform and its unique innovation. And after that, of course, our hardware product manager will give you a little bit deep dive on the hardware spec, on the features, on the module, the developer kit. And then we'll move on to talk about the software, because it's all about AI development, robotics development for NVIDIA Jetson Thor. And we'll talk about how you can leverage the new Jetson Thor software stack to accelerate the development with everything that you want to do. And the third topic is very exciting. As I mentioned earlier, there's a lot of great performance improvement technique that you can leverage to improve your generative AI model and boost that benchmark number. And we newly released VLM container. And also there's a new technique called speculative decoding. And as a result of those, we actually see a tremendous performance boost on Jetson Thor, up to 7x compared to the launch performance. So this is amazing news. And Chitoku will unfold that for you. So don't leave early, so you will see the actual juice towards the end. And last but not least, we'll also talk about a lot of different application framework for you to develop robotic application with ISIC, NVIDIA ISIC. You can also develop a visual AI agent application with the Metropolis VSS, and also using other tools like Holoscan to do sensor processing and more. So stay tuned. We'll talk about everything that you can see here. Let's get started. To begin with, I really want to first talk about how you can solve physical AI problem with NVIDIA 3 computers approach. As we all know, the world is very different now. Physical AI, which means you can basically using AI model to understand the physical world, the laws of physics, and really smartly, intelligently interact with it, is coming. So that is coming. And in the new age of physical AI, what's really important is how you can build a very intelligent model. And eventually you deploy it at the edge and where the data is generated, and to smartly and respond it in real time, right? That's the challenge we are dealing with. And actually to solve that problem, it's not actually starting from the edge. It's starting from the cloud. It's all starting from, using DGX to train your AI models. That's first and foremost. You have some foundation model. And then you actually use simulation to either generate more data to enhance your model performance or fine-tuning your model, or you use the simulation to test, validate your model. So basically you build a virtual environment to test and validate before you even put it into your robots and actually let it start to perform. And last but not least, once you have those models actually test validated with in the Omniverse environment, you bring it to the physical world on NVIDIA Jetson. NVIDIA works with global software, AI, and robots developers to really accelerate their full stack from end to end of this journey. As Thor arrived in late August, NVIDIA 3 computers will be all powered by Blackwell. So this is very exciting. We love to share how you can do this more and more successfully. This is just starting point, right? Things we just introduced Jetson Thor. So you will see how you can use this powerful platform to build the next generation of the robots. And to talk about the robots, actually, you probably already sense that this industry is no longer the same as before. And the driving force of the crazy innovation in this space is generative AI. And let me explain a little bit why we are seeing this change. In the past, robots are single function, program-based, rule-based. And a lot of time you will see those are deployed in mass manufacturing space like automotive, like in industrial manufacturing space, just because they have the scale and they have the resources to program those robots to just do one thing good, very good. However, that's time consuming. It's not scalable. It's not very easy to transfer to a new skill set. And the robots that we're seeing in tomorrow will be general purpose. What do we mean by that? Those robots will have a powerful brain that's powered by generative AI model, such as VLM and VLA, vision language model and vision language action model. And those models can be able to understand human language. For example, you can ask questions like, oh, pick up something for me, pick up the box, take this car to a station, right? The robots can react to it and really reason through it and use tools to understand it and then eventually take and do it very quickly. And that's what we are trying to do at the end of the day. And all of those amazing capability that you can see and you can imagine that happening all require one fundamental capability. That is real-time reasoning. And that is the key to unlock all kinds of physical AI and robotics application. And I'll give you a few examples how we think about this, right? The hottest topic today in Silicon Valley is humanoid robotics. And this type of robots is basically a human embodiment, and it has a lot of different processors on the head, on the hand, and then it's required to perform tasks very flexibly in your kitchen, in the industrial setting, to assemble stuff. And those robots often require real-time sensor processing, running an end-to-end VLA. We see a lot of companies moving to that direction, and also have real-time actuation. And think about that, right? If you don't have real-time reasoning, the robot's gonna crash. It won't be able to do the task as you talk to them. That's gonna be a failure. So that's why it's important. If you think about the other physical application, like let's say you build a visual AI agent to be able to understand the spatial, right, information and understand the context in your space, to do a custom alert, to summarize the video footage for you. And you might see this a lot in space like in a warehouse. You want to understand if there's anything happening, if there's an incident, for example, some boxes fall on the ground, you want to ask what's going on, right? What happened, right? Those type of agents needs to also understand the thing very quickly. Real-time reasoning matters. Medical space. We see today's medical robots get much more smarter. It's not just doing AI detection, classification to be able to find your tumor, where the location is, but also you need, if you build a surgical robots, you need to be able to actuate. You need to be able to summarize what's going on during your surgery. You need to be able to find the information for the surgeon to better access to the resources. Like, oh, bring me the CT scan. Bring me more information from the doctor, like the history of this patient. Real-time reasoning matters. We have a lot more example for autonomous tractors, AMRs, even Edge HPC, where you want to real-time sensor processing. All of those things, reasoning matters, and that's why NVIDIA creating NVIDIA Jetson Thor. Thor is the ultimate platform for physical AI and robotics, and it is super powerful. This is the best processor with the highest amount of compute in such a small form factor. Think about it, it's delivered up to 2070 FP4 flops, powered by Blackwell GPU, with the capability of new transformer, but also the multi-instant GPU features that you can separate the GPU virtually into 2 instances and do workload isolation. It have up to 14-core Neoverse ARM CPU for real-time processing, with 128 GB, large unified memory, 273 GB per second, memory bandwidth to inference large generative AI model in real time. And moreover, the connectivity is amazing, right? It's have 4x connectivity. Sorry, slides move a little bit. So it's have a 4 by 24 GBE connectivity, and also it's just only 130 watts. This is publicly available today, and a lot developers can actually buy it globally from our distributor and even on Amazon. And compared to Orin generation, the processor it just have a giant leap of performance, 7.5x AI performance compute, 3.5x Orin energy efficiency, and then it have a 3x CPU performance, 10x I/O throughput. So overall, this is amazing performance piece for anything that you want to build. Now I will bring our hardware product manager to talk more about hardware features. Ayush, over to you.
Thank you so much, Chen. So as Chen highlighted in the last couple of slides, Thor is the ultimate platform for physical AI. And you can see here the compute specifications of Thor compared to Orin. From 2048 ampere CUDA cores in Orin to 2560 state-of-the-art Blackwell series GPU on T5000 that enabled 2 petaflops of FP4 performance, best in class. And on the CPU side, Thor offers 14 of the latest ARM Neoverse cores. This increases the CPU performance on Thor 3.5x compared to Orin. And for your large model needs, we have increased both the memory size and its bandwidth compared to Orin. Now, Thor offers up to 128 GB of LPDDR5 in its T5000 variant. Thor also has 10x the I/O bandwidth compared to Orin, up to 100 Gbps with 4 by 25x GBE. The module power for T5000 ranges from 40 watts to 130 watts, and for T4000 ranges from 40 watt to 70 watt. And you get the best-in-class performance of 2 petaflops in that power envelope. On the mechanical side, the good news is that Thor modules are form factor compatible to Orin, so you can just same shape and size and use the same module. So how can you get started on Thor? All the Jetson Thor documentation is publicly available on Jetson Download Center. And we have listed some of the key documents that can help you get started on your journey, build your next powerful edge AI application. So far, we talked about the powerful Thor platform that Chen explained, and we saw the highlights of its configuration. But I wanted to highlight something more, some more key challenges that we've seen bringing the high fidelity sensor data to that powerful compute unit on Thor. The first is what we saw users were looking for a really low latency sensor ingestion, especially in humanoid robotics. For example, real-time and tight control loops is essential for humanoids. Being able to bring in sensor data into GPU memory is very important. And the next challenge was the time-consuming sensor integration. Many users have multiple different kind of sensors, and maybe want to get they may want to change their sensors during their development. They don't want to have to go to redesign their hardware every time they make a sensor change. Today, users may have to do extensive driver development in the kernel space, and that can be very time-consuming. And the next challenge was many users and developers are looking for security and safety for end-to-end data transfer on their sensor platforms. Now, this is why we created Holoscan Sensor Bridge. Holoscan Sensor Bridge is our sensor to Ethernet streaming platform. It is targeted at the use cases that you see here. So in humanoids and robotics applications where there are multiple different kinds of cameras as well as sensors like IMUs, actuators, audio sensors. For medical instruments, there is ultrasound, cameras, and the scope. For example, HDMI and SD are also important in medical instrumentation. Communication systems like 6G as well as test and measurement applications where being able to connect data converters to the compute platform is essential. So all this commonality across these use cases is the need to bring high bandwidth sensor data into the compute platform Thor. This is where Holoscan Sensor Bridge will enable you to do that simply. The first value proposition of Sensor Bridge is its ultra low latency. Many of these use cases are looking to get sensor data into GPU memory, and Sensor Bridge enables that at utmost lowest latency. Next is the easy to use development. We have several examples where users were able to add a new sensor in a matter of hours compared to historically it would take them weeks or months. The next is scalable. So some of our customers are looking to have one sensor architecture but have different amount of applications in compute. So they may have different they may have kind of 3 different t-shirt sizes, if you will, a small, a medium, and a large application. Today the way that they would develop this is they would have to go design custom hardware and software for each of these different applications. Because their sensor, even if their sensor architecture was the same, the compute architecture and the way the sensors are connected to the compute would be very different. And in terms of more details about the scalable architecture, because sensor bridge is based on Ethernet, and Ethernet in its foundation is very scalable in nature, and that enables you to have one sensor architecture that you can just daisy chain more compute as you need it. The next is safety and security. And that's where we have built into Sensor Bridge up to SIL 2 level end-to-end safety protocol. Next, let's jump into how a little bit more details about how Sensor Bridge and how it works. So we have developed a custom UDP protocol. Sensor Bridge is a software solution that runs on a partner hardware. In this case, it's a UDP protocol that's running on an FPGA that you can connect it to our compute platform via MGBE for now. The other thing is to highlight that it enables you to take any kind of I/O, so MIPI, LVDS, JSD, and it does both data packetization piece as well as the control piece. So I2C, SPIs, and GPIOs are all configurable within the Sensor Bridge architecture. So how do you get started with Holoscan Sensor Bridge? It is the NVIDIA software that we are providing to streamline your sensor to Ethernet development. We have FPGA partners to provide the hardware. There are 2 FPGA partners for the multi-gigabit Ethernet solutions, Lattice and Microchip. You can see there are developer kits which are available today for you to jumpstart your development. This will enable you to have a developer kit that has Holoscan Sensor Bridge IP as well as the camera connector for connecting cameras. And with this, I would like to pass over the baton to Chitoku to take us through our Jetson software stack. Over to you, Chitoku.
All right, thank you, Ayush. Okay, so NVIDIA Jetson software stack. NVIDIA is sometimes referred as a hardware company or semiconductor company, but NVIDIA actually offers a huge library of software. This slide is a little bit busy diagram. You don't need to remember everything, but I'd like to highlight 2 things. NVIDIA provides amazing array of software, and they work together, sit on top of each other. That's why sometimes it's called software stack. And they are universally available across all the 3 computers: DGX for training, OVX for simulation, and Jetson AGX, our 3rd computer for Edge AI. This is remarkable. You don't get this on other embedded platforms. When you are to deploy to the device, you often would be stripped off from many of the software, almost like an infrastructure that you as an AI developer have took it as granted. Now you need to develop all the custom solution for your hardware. That's not the case for Jetson. Jetson can get all the NVIDIA software stack. That's one. And on top of that, NVIDIA offers a specific software for Jetson, specifically for the Edge AI computer use. BSP, we call Jetson Linux, based on Ubuntu 24, with all the custom kernel drivers to enable our hardware. Security is important because Jetson is going to be physically deployed in the customer product. So we take it very seriously. So we offer solutions for that. So in summary, Jetson gets you covered very well in terms of software through the software stack that we offer. Moving on to the next slide. This is another slide packed with information. JetPack 7 is released in August, and it came with all the complete feature, making this a production-ready software. There are so many features. I'm not going to name and explain all of them here, but a few things I'd like to highlight. Jetson Thor has Blackwell architecture DPU built into the SoC. And JetPack 7.0 or the bottom BSP layer, Jetson Linux of that with its GPU driver supports it. There are many great perks come with supporting Blackwell, like MIG, multi-instance GPU, which we were going to cover later, supported in upcoming JetPack. And SBSA, that's another great feature, and that's already available today. There is also some of the feature related to camera that we'd like to highlight. HSB camera and the SIPO to support it. We're going to touch upon them a little later. Installation and flashing. So if you are to develop on Jetson Thor, getting started on Jetson Ajax developer kit is the best way to go. And traditionally, for getting started on our Ajax platform, you'd often need to start with getting a host Ubuntu PC to flash the Jetson device from your PC. Finally, not anymore. We are introducing a USB disk installation mechanism. What you can do is to use your Mac, Windows, or whatever client PC that you usually use, download the ISO image from NVIDIA Jetson, NVIDIA website, and just flash the USB drive with it. You can then take the USB thumb drive, push into Jetson, and after some hitting enter keys, your Jetson is going to be ready with the BSP fully set up on your Jetson in about 12 minutes. So this is much quicker way to get started. Of course, you can actually use the traditional way of using your Ubuntu PC to externally flash it, be it using SDK Manager or the flashing script. So those are still available. But if you're just like getting started on Jetson Ajax or Thor developer kit, the ISO is the best way. That is documented well in our online user guide in the quick start guide section. So you can go through this step by step and you will be ready in no time. I have talked about other ways to install or flash BSP, Jetson Linux, that is SDK Manager and Flash script. So those are laid out here as well. SBSA. So Jetson Thor is now, or Jetson is now finally SBSA, server-based system architecture. This is being enabled by our new, well, for us, for Jetson, it's a new type of GPU driver called OpenRM. We have been using NVGPU driver, which was architected specifically to enable our iGPU on the SoC, which was different from the driver architecture that's employed on the desktop GPUs or our x86 GPUs built for x86. That has been OpenRM. So we finally sort of migrated to OpenRM. What this means is that we are now on the same platform as the other ARM-based NVIDIA computer like DGX Spark and GB200, those DGX lineup in, working in the data center. It really streamlines the developer experience in the pipeline, and the developer can take the same pipeline for all NVIDIA ARM platform. You can actually see that on Jetson Thor that you can today use some of the tools that was developed for traditionally the desktop system, like NVTop. So you actually see an immediate benefit of this, and you will continue to get benefit by having a universal integrated pipeline across all the NVIDIA ARM platforms. CUDA 13s. That's another great feature of JetPack 7.0. This is the latest release of the CUDA. And we actually have a very technical detailed blog about what's enabled on CUDA 13. And they are all mostly actually enabled on JetPack 7.0. So SBSA, I covered that. Multi-process service, that's already supported on our Jetson as well. The only one thing that comes later is the multi-instance GPU. That is going to come in JetPack 7.2, which is slated to be early next year. JetPack 7.1 will come this year to support the upcoming Jetson T4000 module. little brother to the T5000 module that is packaged in the JetPack, Jetson AGX developer kit. Camera APIs. So for the MIPI CSI camera that goes directly interface to our SoC, we have been offering Argus and the Argus library and its own API to make them work for your applications. That's still supported here on our latest JetPack. But what we introduced is a new API and a framework called SIPO, or library called SIPO. This is to support the Holosensors bridge-based cameras. So what people can today do is to, on top of the MIPI CSI camera that gets directly interface to the Jetson or the Jetson SoC, people can develop an Ethernet-based camera. That's what Ayush sort of covered. And then SIPO is a software framework for that. So those are going to be offered simultaneously for your camera hardware. So Jetson Thor supports all modern Gen AI framework and models. What's great about Jetson is it's an open platform. It's not tied to one specific AI company, AI provider, or model provider. NVIDIA supports all the major Jetson, AI framework, and thus Jetson supports all of them. So on the right, you see major framework from the various companies across the industry, including TensorRT, that is NVIDIA's. But like you can find PyTorch, TensorFlow, and some major players like Hugging Face. You will see all those software being nicely supported on NVIDIA platform, of course, as well as Jetson. And even what's great about Jetson is that the latest Jetson Thor comes with 128 gigabyte memory. So it can even handle some of the big models that is being released by our players, like GPT-OS's 120 billion models, physical intelligence's OpenPy, which is actually a remarkable vision, language, action model that's going to that's expected to serve a huge role in physical AI and especially robotics. So all the great advancements that you will see, you today see in the industry, we get to have access to them on our Jetson platform. That's a great benefit of Jetson being an open platform and supporting many of the framework out here. So today people talk about the inference engine a lot. Some of the notable players being VLLM, SGLang, and those are actually going to be and is officially supported by NVIDIA. Today, if you go to NGC, you will find the VLLM container pre-built and ready to be pulled by you. So a VLLM is readily available on your Jetson Thor. If you find other framework like MLC, you still want to run on your Jetson, there is another approach. So instead of going to NGC, you can actually turn to our very active community solutions maintained by our active community members. So Jetson AI Lab is a hub for you to learn all those activities. And in the background, we have Jetson Containers, a software framework to build and deliver such containers through the community effort. You can find the MLC and the other software through that pipeline there. So this is another great topic that we want to cover in this webinar today. So Jetson Thor was released. Jetson Thor or Jetson AGX Thor developer kit was released late August this year, and we have less than 2 months, but we are seeing this huge increase in performance already thanks to all the software optimization and inference optimization happening. Let me sort of walk you through what actually contributed to achieve this great result. You can actually find a tutorial to actually get this great number performance hop on your Jetson Thor by following this tutorial. So you can difference this later. But to walk you through, so first of all, we have some mechanism to support some of the model on day 0. I mean, that really is a benefit of NVIDIA GPU is being used across the industry. So when GPT OSS came out, it was supported by official. It was supported on Llama CPP. Llama CPP is already supported on Jetson, so it is supported on day 0. And now VLM container is released through NGC. And VLM comes with many of the great recent features, like speculative decoding that I will mention later. So those are going to enable some of the model being available on the day 0 on our platform. This is, again, a huge contrast to other platforms that you'd need to spend months, if not years, to customize and somehow port the model onto a specific hardware. Nemotron is another great NVIDIA effort to bring NVIDIA customized model based on the open source software, open source model, open weight models. And those are also available on Jetson Thor. So these software optimization. Oh, I also want to mention the Flash Infer that many of the NVIDIA's effort went into. So Flash Infer offers all those optimized kernel for LLM. That is bringing some close to 3x performance gain on some of the models. So that sort of provided the baseline to our eventual 7x performance gain. Another great sort of element that contributed was speculative decoding that I mentioned. Eagle 3 is latest speculative decoding framework now offered in VLM. So by taking advantage of this, you get another 2x performance gain. So that's how you were getting like 7x performance gain combined with some optimization in Flash Infer and speculative coding now available on VLM. You're getting this much performance gain. You will continue seeing this kind of performance gain on other model. Today, VLM or Eagle 3 supports covers specific models, but it is expected to expand its support across other models as people are like really now working hard and looking for it. So we'll probably see this trend of things getting optimized and run even faster. Your model gets also supported and suddenly gets this much performance gain. FP4 is another great factor or feature being supported on our Blackwell GPU. Those are taking advantage. Those optimization techniques are heavily utilizing such new quantization and features, hardware features. So yes, the NVIDIA Jetson is a great platform to sort of witness and continue to get the appreciation of all those advancements in the inference optimization. Jetson AI Lab. It is now an integral part of the Jetson developer experience, and NVIDIA is committed to support both the Jetson AI Lab, the hub for the developers, and then also the tool behind it, Jetson containers, a framework to deliver and build the containers for each applications. We have already introduced a benchmark tutorial for Thor on that. Some of the tutorials are already supporting Thor, and we are actively working on supporting more converting tutorials to support Thor right now. We are also very actively working on the Jetson container right now. We need to go through some migration. You have already seen our Jetson Pipeline server move to a new domain, and which is already announced and migrated into Jetson container. We are going to also find a new hosting place or the container registry where those container images are going to go into. So those are going to be planned in November or December. We are like really, as of now, actively working on this. So we will probably have more news around it. But what we want to tell right now is that NVIDIA is committed to support those in the Jetson container. They are not going to go away, and we will be able to provide more information on those in the very near future. The Thor software roadmap. We kind of touched this in a couple of slides before, but yes, JetPack 7.1 will come later this year to support the upcoming T4000 module. JetPack 7.2 will come early next year to support Jetson Orin series, and finally enable the MEG for Jetson Thor. So those are already planned and they are to come. Lastly, I'd like to conclude my part by showing some of the demos that we prepared to run on Jetson Thor. So the first thing is Isaac GR00T, hardware in the loop demo. Isaac GR00T is a great vision language action model that NVIDIA provides. And it's remarkable. It shows a very amazing performance. So to demonstrate that, well, it would be nice that everybody has a humanoid sitting next to you to be hooked up to Jetson Thor, but that's not likely. So what we decided to do is to actually bring Jetson computer's brain sort of into the simulator and make it perform the humanoid task. The way how it works is that we are going to pair Jetson with very powerful OBX or RTX computer. It's an x86 computer, your PC running Isaac Sim that simulates the whole environment with where your humanoid sits and then trying to perform a certain task. We are demonstrating this GR00T N1 model that is specifically that is fine-tuned to do this nut pouring task using two hands, two robotics arms. So this is after the fine-tuning. This is to validate the inference, performance, and accuracy in the realistic setup. The very realistic eventual setup would be the real world, but the one step before that we are replicating that people want to go is the simulation and the simulator with the hardware in the physical environment to like really simulate the thermal load or actual GPU limitation, the edge AI compute limitation. How it actually works is the simulator, Isaac Sim, is going to render the scene from the perspective of the robot humanoid camera. That image is going to be transferred to Jetson, streamed to Jetson. The model working inside of Jetson doesn't know it's coming from the real camera or a virtual camera simulated in the simulator, but trying to diligently try to perform the task that it was taught, and eventually spits out the series of motor actuation commands to manipulate all the joints of the humanoid. And that gets fed back to the simulator. It in turn moves the simulated robot in the simulator And that result in a new camera frame that gets rendered by the Isaac sim. So you see the loop around. And by doing this, we can effectively simulate how a model, a fine-tuned model, would perform in the real world on the actual robot, but like without risking potentially destroying your humanoid. There is actually a great video. Yes, so this is how it works. The little window on the right below is a terminal that's showing some of the message coming out from the Jetson. So that shows what's running on Jetson. The screen you see is on the PC running Isaac Sim. So this robot is being kind of manipulated by the Jetson. If I yank out the keyboard, the robot actually hangs because it's almost like you're putting a jack off from the Neo in the simulated world or the reality in the movie Matrix. Another great demo we like to highlight is VSS from the Metropolis framework. It's been running on the x86 server machines and the workstation, but now it's possible to run on Jetson Thor. So let's see this video. This is going to nicely walk you through the demo. We'll see.
We are excited to announce the new event verification feature in Video Search and Summarization AI Blueprint. In this demo, you will see two main components, the computer vision pipeline and video search and summarization block. The CV pipeline uses grounding Dino to process video input, detect objects, and generate clips of significant events. VSS then processes these clips to verify the events and generate alerts displayed on the dashboard. In the computer vision pipeline manager, the user can first configure our input stream, define the detection parameters. For instance, here we define a cardboard box, and then specify a VLM prompt. This prompt is sent to VSS along with the event for further analysis. Once the user clicks on process, the CV pipeline detects the events and sends it to VSS. Here you can see all the alerts being shown on the VSS Alert Inspector UI. For a given alert, you can click on the Info tab to get the metadata for that alert. You can see the stream ID, alert configuration, and other settings. User can then click on the chat button to further ask questions for a particular clip. Here, we ask the agent to describe the condition of the cardboard box, and it replies back saying that the cardboard box seems to be slightly worn with visible creases and some damage. We can go back to the dashboard and ask another question for another clip, like are any of the boxes getting stuck or getting damaged, and the agent responds back no. So this feature can greatly enhance the current computer vision pipelines by adding additional insights.
Okay, yeah, it's frankly amazing all of that is working on this tiny little computer, Jetson Thor. All right, so that wraps up my part, which covered the software stack, performance gain we have already achieved, and great demos. I'd like to pass the baton back to Chim.
Thank you, Chitoku. So before we jump into live Q&A, I'll give you a few quick links for you to get started. First, go ahead and explore Jetson Thor on the webpage. We also have a launch technical blog that you have a link here that talk about all the benchmark that a lot of people have asked earlier. Second, we have unboxing video to introduce the Jetson Thor developer kit. It's an amazing video that's going to show you what's actually inside and also how you use it. And meanwhile, there's some demos that showcasing variety of workflows. Third, please read the Jetson Thor technical brief that explain the Thor platform from hardware architecture perspective. And also, we will have a new blog to talk about how you can achieve the 7x performance boost on the Jetson Thor with the new VLM container. So it's coming very soon, in probably later this week. So stay tuned on that. Last but not least, go ahead and order a developer kit if it's available globally, and have fun with the beast. And now we will look at the question and start to answer all of them. We have 15 minutes. So I would invite all of our team members just to turn on your camera. We also have today our product manager Suhas here. So Suhas, turn on your camera as well, so everyone can see you. We'll look at the questions one after another. The first question is really on the hardware side. So I'll ask Yush. In the past, we have a Jetson product based on industrial SKU. How do we handle that right now with the Jetson Thor? And also, how do you handle safety, functional safety specifically?
Yeah, thanks, and great question. So on the industrial side, Jetson will not have an industrial SKU, and if you want to use higher shock vibe temp configurations on these modules, you'll have to go to IGX platforms, and that is true for safety as well. All our safety configurations and safety platform and safety software stack is enabled on the IGX, but not on Jetson. But if you want to use a ruggedized system, you can look into our platform partner platforms. There are some great options out there.
Cool. Another question. Is there a plan to launch AGX Thor developer kit based on T4000?
No, the developer kit, AGX Thor developer kit, is based on T5000, and that is the high end option that we have.
Got you.
I would like to add something. We will release a power mode with which you can emulate T4000 on T5000. So it's the same developer kit, but you can put it in a mode in which you will see the performance of T4000.
Yeah, thanks, Suhas. Yeah, good point.
That's great. So basically, it's the similar feature as we introduced AGX Orin developer kit, right? You can do emulation. Fantastic. Well, what would be the difference between T4000 and AGX Orin 64GB? When to choose the T4000 over AGX Orin or vice versa? Or in other words, will T4000 replace AGX Orin 64GB?
Again, a great question. So we have been developing Jetson for over 10 years now, and with Orin, we released almost 7 different SKUs on the same SoC architecture that are intended not only for today's application, but for future workloads as well. We extended our product lifecycle on Orin till 2032. So with this, Orin will live for a really long time. And we will continue to make improvements on our platform from software end. So for entry level, you have some of the Orin SKUs, but if you talk about 64GB, there are some key differences. Example, a MIG is enabled on Thor. And then Thor has the latest Blackwell generation of our GPUs. A similar power envelope, a similar form factor, but there are key hardware differences. A latest PVA inside it, more CUDA cores inside it, latest ARM CPUs inside it. So based on your workload, you can see which fits your needs the best, and the performance is definitely better on Thor.
Gotcha.
I think that is kind of the key difference that you need to analyze to pick one product over the other.
Great, and the T4000 is coming soon, so
Yes.
in November timeframe, you will see it. We'll give you more details. Next question. Next question is about the software side. Have you planned to share optimized model through Jetson Thor on Hugging Face? Suhas, do you have an answer for that?
Yeah, I mean, some of the quantization efforts that we do, like providing checkpoints for NVFP4 and other things, we do put it back onto the Hugging Face. So, for example, if you look at if you do a Google search of say Llama 8B FP4, you'll end up in a Hugging Face page, but maintained by NVIDIA. So you'll see all the optimized models or checkpoints in that NVIDIA maintained Hugging Faces.
Got you. And another kind of related question on the model release. Can you explain the difference between NGC and Jetson containers?
Yeah, I will let Chitoku come in here, but I'll start and then Chitoku can finish the answer. NGC is a platform for supporting some of the frameworks that we officially support, like VLLM, SGLang, and other things like PyTorch. We will support through NGC containers, and these are officially supported containers. But what happens is there is a release cadence, so it is every month. But on Jetson AI Lab, we can go even more faster. For example, 2 days back, I think there was a Qwen 3 VL model came in, and the support for Qwen 3 VL model was there on the upstream VLLM. we were able to create a VLLM containers through Jetson AI Lab and support that model on day 0 of the launch. So you'll see that the Jetson AI Lab will have containers which are more up to date, so that you can start working with the models which have been launched recently, but also some of the frameworks that we don't officially support, but community supported, like Olama, Llama.cpp, and all those things that will be there. Those containers will be there. NGC will be officially supported containers, but with a monthly cadence. Chitoko, if you want to add something on top of it.
Sure, yes. Like Suha said, NGC container, they have typically a monthly cadence. That's why it's tagged as like 25.09. And sometimes it skips the month. So you'd probably see less than a month cadence. The community efforts being concerted on Jetson container, they actually try to support the major inference engines such as MLC, VLLM, SGLang. Yes, those are included as well. So what is possible is for people who are like really interested in getting the top of the tree from the upstream or the main say SGLang or VLLM, they can actually reference how the Jetson containers package is configured to try to build the SGLang or VLLM. So think of that as a recipe for people to learn how they can actually make those inference engine work on Jetson. So that would be sort of like providing an alternative path rather than using VLLM or SGLang container being provided through NGC. What our customer can do instead is to try to build by themselves and support by themselves, right? Rather than using an off-the-shelf container. Jetson container would be a resource knowledge for people to reference how it can be modeled, and oftentimes it try to provide or support of the modern or up-to-date upstream software.
Got you. Okay, thanks. I think there's a lot of question around can you compare and contrast Jetson Thor with DGX Spark, and a question about Jetson Thor and IGX. I think we need to clarify a little bit over there. I think there's the feature to share screen here. So let me see if I can share my presentation. Can you all see my window? Can you all see it? Suhas?
Yeah, we can see it.
I can see it. We can see it.
Fantastic. So I think this we have a quick chart that explains AGX Thor, IGX Thor, and DGX Spark. I'll quickly explain a little bit, and Suhas, you might add a little bit on the software side and expand it. So when we think about those different processors that can be used for the edge, Jetson AGX Thor is really for robotics and embedded AI system, and you got ultimate flexibility to customize the platform for a variety of form factor and different use cases. And IGX Thor is the industrial version of that with functional safety, with enterprise OS, with real-time sensor process capability. And then if you look at DGX Spark is for personal AI supercomputer and general edge deployment. The form factor is kind of not as flexible as the other two, right? And when you look at where it's available, Jetson Thor is available by our channel for developer kit, but for production system is our embedded ODM. And for IGX Thor, because it's built for industrial edge and medical edge, often is the specialty OEMs over there who handle those type of customers. They will build an IGX based system. And then for DGX Spark is really the major OEM like HP, Dell, and Lenovo, versus who build those for consumers who want to buy off the shelf and directly deploy on any use this as a supercomputer for themselves or directly deploy for edge inference. And if you look at AI compute, AGX Thor 2 petaflops, IGX Thor because it have the iGPU as AGX Thor, but also the DGPU capability is can go up to 3,511 T-flops with a Blackwell DGPU. You have that, and then 2 petaflop on the iGPU. Totally is 5,500 T-flops. It's a lot more compute that you can have. And for DGX Spark, it's 1 petaflop. And of course, there's some number here. I don't want to reinstate the I/O throughput is AGX Thor, and DGX Spark AGX Thor is close to like 100 GBE. Is a full length 25 GBE, and then IGX Thor is up to 400 GBE because Connect X7, and DGX Spark is 200 GBE. So you have I think the on the software stack side, I'll jump into real quick. Jetson Thor is a JetPack OS. There's really forum support mostly. There's no enterprise support. And IGX Thor, you do have IGX OX, which is enterprise grade. You have NVIDIA AI Enterprise software stack, and also the business support with it. And for DGX Spark, it's using the same DGX base OS. And you can run names, blueprint, things like that. So and for the use case perspective, right, Jetson Thor is really the humanoid robotics and also all verticals, indoor, outdoor, and all physical applications, very flexible. IGX Thor really for industrial edge, medical edge, and the DGX Spark is general research. And if you want to deploy it as edge inferencing, mostly it's indoor because it doesn't have the ruggedization and the industrial or even like capability. And I think the temperature range for that is kind of narrowed compared to Jetson. Suhas, you want to add a little bit over there?
No, I just want to take one question from here, related question. So
Sure.
this was, what's the difference between IGX Thor and Thor T5000, which is AGX? There are, if I were to just, Chen already answered that, but if I were to just say in bullet points, three major differences. One is industrial grade. IGX Thor is industrial grade, while AGX Thor is not. So high temp, high vibe, ECC, all those features are available only on IGX. Second is functional safety. If you're a robotics use case and you need safety, IGX is a platform which brings powerful AI and safety into one single platform. While Jetson, there is no safety. Third bullet point where they differ is the enterprise stack. IGX is supported by long-term enterprise stack, so we can support the entire stack for up to 10 years. Jetson is not an enterprise-grade software stack, so we support it through JetPack for 5 years. So those are the three main differences.
Cool. Thank you, Suhas. Probably we only have time to do 1 or 2 more questions because we are on close to the top of the hour. The next question is on the camera support. Usually you mentioned Holoscan sensor bridge, but what are the other camera protocol that you supported on Jetson Thor?
Yeah, so Jetson Thor T5000 has support for maybe CSI, and but you can use any sensor or camera for that matter using the Holoscan sensor bridge, which brings any interface of your choosing onto the Ethernet output that can connect directly to Thor developer kit or Thor modules.
Yeah, and also our ecosystem offers GMSL cameras, USB cameras, all type of camera that for your development and deployment. Last question. I see a lot of things about MIG. So Suhas, can you explain a little bit on when we will support it and how it works? Oh, you're on mute, Suhas.
There has been multiple questions on multi-instance GPU. I just want to make sure that people do understand that what is multi-instance GPU. Multi-instance GPU does not mean that we have 2 GPUs on Thor. It means that you can split the existing GPU that we have on Thor into 2 separate instances. So for example, you can split a AGX Thor GPU into 1:3 and 2:3. Now it will behave as if there are 2 independent GPUs, but since you have split it up, the cores available for you for each instance is reduced compared to what it was when you have not split it up, right? So big enabled versus disabled. I just want to make sure that it's not somehow magically 2 GPUs. Secondly, the use case for multi-instance GPU has been a more predominant use case is actually mixed criticality, where many of your use cases will have certain models which are extremely critical and hence need to complete deterministically, or should not be fighting for resources from other low priority models. So you can actually do a multi-instance GPU, put into 2 instances, and have 1 instance only for your higher priority models, and let all the other GPU workloads fight it out on the other instance. So this way, mixed criticality is one of the main use cases of multi-instance GPU. It's not enabled in JetPack 7.0 right now. It will be enabled in JetPack 7.2 in Q1 timeframe. So that is one more information.
Thank you, Suhas. I think that's a great question to wrap up today's webinar. We'll have more of this type of engagement in the future. Stay tuned with us, and thanks so much for your questions. It's super engaging. It makes it very interactive for us to talk through your concern, your questions, and look for if you have more questions, feel free to ask those in the forum. We have a staff member there to help you address them. So with that, I'll say thank you very much. I'll see you in the next one. Have a good day. Bye-bye.
Thank you.
Thank you.